trapezoidal sum is a method used to approximate definite integrals. To calculate a trapezoidal sum, we first need to know the area of a trapezoid, which is base 1 plus base 2 divided by 2 times height. Now we can calculate a trapezoidal sum on the interval a to b using data x0, y0, x1, y1, etc. The trapezoidal sum is equal to the integral from a to b of a function divided by b minus a. We can then write this as 1 divided by b minus a times the sum of the subintervals of the function. The value of a subinterval of the function is equal to the sum of the two y values divided by 2 times the difference between the two x values. Here's an example. People begin waiting outside a stadium at 5 p.m., t equals 0, and continue to enter for 4 hours. The number of people waiting in line at time t is modeled by a twice differentiable function f for t is greater than or equal to 0 and less than or equal to 4. The data is shown in the table above. Use a trapezoidal sum with 4 subintervals to estimate the average number of people waiting in line during the 4 hours that people can enter the stadium. We can now set up the integral of f of t from 0 to 4 and divide it by 4 minus 0. We get 1/4 times the sum of the subintervals of f of t. We can plug in values from the data table and eventually get 651.25 people. This answer means that at any time between t equals 0 and t equals 4, the average amount of people waiting in line is 651.25. This concept can apply to real-life situations such as concerts and sporting events. Management can use techniques such as the trapezoidal sum to determine how many people are waiting in line at a given time. They can then use this data to design entrances appropriately and assign the correct number of employees to an entrance in order to avoid causing long lines. These are the sources I use.